Thank you. Hello, everyone. Thank you for your patience. We were waiting for the rest of the participants to join. My name is Santiago Lopez. I'm the moderator for today's webinar. Very excited to be here with you. I'm part of the analytics committee and part of the Colombian Actuarial Association. Been working in the topic of large language models and applications for some years now. I'm quite excited to be presenting our dear presenter, Małgorzata Śmietanka. This is a very exciting application of large language models that we're going to have here today. So just to present her, Małgorzata is an actuary with a PhD in computer science and a researcher of the University College of London. She chairs the Federated Learning Working Party at the Institute and Faculty of Actuaries and fosters collaboration between industry and academia. She has hands-on experience in the actuarial field, particularly in life insurance. Her work focuses on large language models and privacy-preserving AI, apologies, with a strong emphasis on practical implementations in the insurance industry. So welcome, Małgorzata. Once again, amazing topic. We went through it yesterday. It's really a great, very well-developed application that we're going to see today. All right, shall we move on to the next? And before we start, just some housekeeping. So we have turned the microphones off, but please do interact, do submit all of your questions with the Q&A button that you will find at the bottom of your screen in Zoom. And then we will try to go through the most of the questions that we can at the end of the presentations. Questions that we cannot pick up, we'll follow up on them by email. We'll be reserving some 15 minutes for your questions. And then, yes, the recording will be available. Yes, the presentation will be available for you. It will be made available within a couple of days or so. All right. And of course, our usual disclaimer. So just please be aware that the information presented by the authors or the presenters in this webinar do not necessarily reflect the policies or positions of the International Actuarial Association. And I'll let you read through the rest, which you probably already know. And with that being said, let's start. Please, Małgorzata.
Thank you, Santiago. So imagine you are a claims handler at a large insurance company, and it's 9 a.m. in the morning, and your inbox is already overflowing. You open the first claim. It's a hospital stay. You have attached PDFs of admission records, discharge summaries, doctor's notes, and even a few handwritten scans. Now, multiply that by, say, 50. And your job? To decide whether each claim should be approved or denied. And you have to do it quickly, accurately, and fairly. So you need to spot any inconsistencies, check any exclusions, and ensure compliance with internal guidelines. All of that while under pressure to keep processing times short and costs low at the same time. And this is the reality of thousands of claims handlers every day. And the volume of unstructured documents is rising. And the policies are getting more and more complex. But decisions still rely heavily on manual reviews. So people just reading the documents and deciding whether a claim should be paid or not. This all is not just time-consuming, it's also risky, because errors can lead to customer dissatisfaction, regulatory breaches, or even financial loss. Try to move on. Now imagine you have an assistant, the one that never gets tired, that can read in multiple languages, and that can understand medical jargon, legal exclusions, and even handwritten notes. And that's what a large language model can be for a claims handler. You upload a claim file. The LLM scans the documents, the discharge summaries, lab results, or even the footnotes in scanned PDFs. Then it highlights the key facts, like the length of hospital stay, diagnosis, the special codes of the medical procedures, and finally, whether treatment falls under the exclusion clause. The system doesn't make the final decision though, but it gives the handler a summary, also flags potential issues, and explain every step of the decision process. And you can think of it as giving every claims handler, every claims analyst, a superpower of speed, of consistency, and deep contextual understanding. As a result, instead of spending hours on repetitive tasks, your team focuses on edge cases and customer support and care. Processing time can drop from days to hours, and errors go down. As a result, satisfaction goes up. So welcome in the world of LLMs. Now, let's try to process a claim. We have chosen to focus on medical claims because those are among the most document-heavy and complex types of claims. They're rich in jargon, often very urgent, and very difficult to automate from that reason. But all of that, it's not limited to the healthcare, it's just an exemplar. The same approach, the combining secure documentation handling and the power of LLM can be applied across the whole lines of business, whether it's property claims, liability, or like fraud detection. Anywhere where you have piles of unstructured text, ambiguity, and need a fast, very accurate, explainable decisions. This technology can help. So now, as I said, we will be processing medical claim. The story is as follows. This is a real-life claim of my son, 1 year old at a time, say Tom. The data was anonymized for that presentation. And what happened? My 1 year old son just started walking, and he bumped his head against radiators. He tripped over, bumped his head. And at the same time, he started to behave not himself. Usually very active babies started to be lethargic, have fever, very cuddly, totally not himself. As a young parent, together with my husband, we decided to refer him to A&E to check what's going on. He was kept for the overnight stay in a hospital for observation. At the hospital, they concluded at the same time he had a viral infection. So it said on the second page, viral tonsillitis. But we'll go through it in a second in detail. So let's process that claim. Let's switch to the demo. All right. We are now in claims processing platform. We start with uploading the medical document, the hospital discharge letter, which is this one. And we upload the insurance certificate. So at the time we had an insurance policy, the health insurance policy. I'll hit process document. So we had the insurance policy document that paid for each day of hospital stay. No matter the cost of the hospital cost, there was a daily rate associated with specific type of hospital stay, whether it was accident or disease or other medical procedures. Each of those types of hospital stays were mapped to a daily rate, and the payment is the number of days of hospital stay multiplied by that rate, which had to be figured out by claims handler. So the analysis is complete. Let's look at the result. What we have here, we first identified the main reason of hospital stay. And we have here that the patient was hospitalized for the viral tonsillitis, which is true, lethargy, fever, and observation following a head injury, which is exactly what happened. If we look at the medical document, so the viral tonsillitis is taken from the diagnosis, and all the rest information is extracted from clinical summary. It says exactly same. Presented, like the patient presented with concern of being not himself, lethargic and fever, and the following summary. Then we classified the type of stay. Here, the system classified that stay as disease, because the patient was diagnosed with viral tonsillitis, but also as an accident, because that was the main reason I referred him to the hospital. And the system mentions the head injury here. So again, correct classification. We follow by some general information extracted both from insurance certificate. So from insurance certificate, it's important to make sure the claim follows under the period insured. So we take the insurance cover start date. So from the uploaded certificate, it's 1st of September 2020. Then we check for the hospital admission and discharge date. It's important for this type of insurance because we pay daily rate for each day of hospital stay. So we have to figure out how many days the patient was in the hospital. So we have hospital admission date, which is 15th of October 2021. And we can check that it's true. The admission details are here, 15th of October 2021. Please notice that like the formats of dates may be different. Sometimes it's written with words, with slashes, with different separators to day, month, and year. So the system needs to figure out what is the date. Here in that case, we also have an hour, like the time, the actual time of admission. Then the hospital discharge details. And the system says it's 16th of October 2021. That's a very interesting one, because the discharge details on actual documentation are missing. They're not directly stated. And that's why the platform says that this information, those dates, are inferred. And they are inferred because no discharge date was found. The system is using the latest date from procedures and consultations, medical diagnosis in that case. And we can see that the latest procedure date was 16th of October 2021. We also look at the document creation date because it's very often associated to the discharge date. In that case, it's 16th of October 2021 again. So that's why we put that as an inferred day of hospital discharge date. We follow the analysis by checking for exclusions. insurance policies have different exclusions, and we have to check whether claim is liable or not, whether it falls under those exclusions. So it's very policy specific. If you have different policy and you analyze different policy, you will have different conditions that you'll have to check against. In that case, we check if the hospital stay is a result of warfare activity, active participation of the insured in acts of terrorism or riots. It's no. Then we make sure it's not attempted suicide or self-harm. It's no. At each stage, we give the justification of the answer. Then whether it's act of crime, no. Whether there was the influence of alcohol or intoxication, no. And so on and so forth. Each time again, justifying the decision, not only giving yes or no, but also pointing to the right medical procedure or diagnosis that states it's not the case. After checking for exclusions, we summarize the claim. And in that particular claim, type of policy, as I mentioned, we look for the daily rate of hospital stay. It's in this case, accident and disease, and it's from the insurance certificate. It's 100 zloty per day. So the policy is the Polish contract. The medical history is from the UK. So number of hospital days at the hospital is 1. The amount 100. So the recommendation is to pay 100 zloty from this claim. There is no additional, in the comments section, there is no additional, no exclusions that apply in that case. So as a claim handler, you have everything in one place and just make informed decisions based on all of the data brought together in your eyes. So let's now look at the AI pipeline that powers this experience. So the whole process is divided by data preparation stage and data processing. We start with inputting the document, and we have to extract all the text. We need to do the image processing, which is the very, very first step of the data preparation. Then we OCR extracted text. It can be powered by multimodal LLMs that understand not only text, but also images, videos, and different formats or both. Then we correct errors that come from this OCR extraction of the text. We then structure the document to highlight the section like diagnosis, procedures, maybe medical leave information, admission, discharge date, all depends on the policy and the business process. We also remove personal identifiable information. It is very important, particularly when using the closed models, so the one that you use via API and are hosted in the external cloud. After we have the data preparation ready, we move to the data processing. And as we could see, we first extract medical information, so summarize main cause, identify hospital stay dates. We classify the type of stay as well, whether it's disease or whether it's accident, like the motor accident, often whether it's a cancer disease is a different rate. All of that that the claims handlers do when processing the claim. So that comes from the medical documentation. From the coverage information, so for example, from an insurance certificate or from the internal database of insurer, you extract the coverage information and validate them. And in that case, extract the payment rate for the daily for each day of hospital stay. Once you have that analysis complete, you can save all the data in JSON or Excel format for data governance and audit. And based on all the information brought together in one place, you do the decision recommendation. You always have human in the loop. But you make it easier for a human to make informed decision based on all the information brought in one place and structured. So now let's break it down even more. Let's go step by step by processes. And before we can even start reasoning with LLM, we need to understand what's in the document. And that most of the time means we need to OCR the document because it often comes in an image format. And the OCR is the very first critical step. If it fails or misreads something, the rest of the pipeline is compromised. And that is why we treat OCR not like a black box, like a single function, but as a structured and multi-stage process. So we break it down even further. The first stage is the pre-processing. And what I mean by that, it's image enhancements. So playing with contrast, the skewing image, detection of the layout, separating headers, footers, tables, images. Also, detection of the language and handwriting, because we need to process them separately. And there are also language-depending OCR engines. Once we have the pre-processing done, we move to the actual text extraction. So underneath the hood, there is the OCR engine, and it can be local Python library, for example, Tesseract, Easy OCR, Paddle OCR, or it can be a vendor solution, which you call through API. So, for example, Google Vision or AWS Textract. And it's important to keep in mind that it should support multi-language and handwriting if those are uploaded. As mentioned, it should capture also not only just text, but the whole structure of the document, whether those are tables, separate sections. So all of that we should keep in mind. After we do the text extraction, we then do the post-processing. And what I mean by that, spell checks and spelling correction of all the noise that comes after the text extraction, so the middle stage, and reconstructing of the document flow, because OCR is done by page, and medical documentation or any documents in claim handling process, it's usually multi-pages. Why it all matters? Accurate OCR is the foundation of everything that follows. What's also important, LLMs can help with that stage too. And we will now look at two examples. I would like to highlight the impact of the document quality. And that's why I run two tests on two versions of the same medical document section. It's exactly the same document we were looking for on a demo. So the first version is, the text is very clear and readable. However, there is a slight background shade present, but it's green underneath because everything is perfect. This is powered by a multimodal, large multimodal model. It's interesting because this model is local model, so you can run it on your own infrastructure. It's Llama 90 billion model vision. So the extraction is perfect. One very important thing to note here, it's extraction after error correction with another model, not multimodal in that case. So it's after those 3 stages: pre-processing, extraction the text, and post-processing. If we look at the same document, but rotated with the picture taken from an angle, some more background to this section. And again, the multimodal model, how it handles that one. We can see it's not perfect. The green sections are what's correct. Here is some missing information. So it's exactly, and like the 3rd line, which is very in angle. We also see an error of misaligning of lines. So those 2 should go together, and they're in different lines. But having said that, this level of accuracy of extraction, it's enough to do the reasoning correctly. But I'd like to stress here how important is the quality of the document that we are processing. So this was after error correction with LLM. If we now compare OCR powered by LLMs with pure Python solution, we will clearly see the difference. So on the top, we have 2 LLMs. On the left-hand side, the large LLM, 90 billion multimodal model. On the right-hand side, in the first top line, it's smaller model, 11 billion. So you see how important is the size of the model and the type of the model. And we compare that with the Python results. At the bottom, here is the paddle OCR. Doesn't give any meaningful information, and Tesseract even less, doesn't extract anything. So we can see how powerful LLMs can be in supporting that text extraction process that is crucial in further analysis. So now let's move to the anonymization. So in claims processing, documents often contain personally identifiable information. What I mean by that, it's names, addresses, phone numbers, national IDs, medical records number. And all of this information is protected under regulations like GDPR in Europe or other regulations, for example, in the US. And like those frameworks require data controllers and handlers to implement safeguards and protect that individual information. GDPR also restricts the data movement, so those information have to be really, really carefully handled. And when automating claims processing with LLMs, and especially when running the models that are hosted in the clouds and called via third-party APIs, like raw personal data should be removed, should always be removed. And so the anonymization is the essential step when someone wants to go to the cloud. But what I want to point out here as well is that even anonymized data should be treated with care. For example, like imagine a document describing a rare surgery, like with very unique procedures, followed by specific rehabilitation plan, like in a very particular region. Even without names or contact details, this sequence of events can be cross-referenced with leaked discharge summaries from the hospital. So I have my document of my son, but the hospital has it as well. If they leak that information, And I just assume that marking it in black of the document makes it safe. It's not safe. Some procedures, like procedures, the name of the doctor, all of that can be cross-referenced. So I just want to stress that even anonymized data should be treated with care. And like on that, always when choosing your LLM, it's good to check providers' data handling policies to make sure like you opt out from using your data to further training the LLM model. So how do we make sure the documents are safe for processing? So there are some smart anonymization techniques that can help. So it's not just marking the names with black bars. There's a handful of techniques that we can use, and let's go through them. We can use the set membership matching that detects known names, streets, hospitals, for example, John Smith or Baker Street, and masks them. So for example, when the section is identified, we mask it with X's or leave it blank. Another technique is regular expression pattern matching. It's very good for finding emails, phone numbers, national IDs, or postcodes. The example is john@email.com. And for that, there is a number of Python libraries, for example, regex. It's advisable to normalize the whole text. And what I mean by that, it's removing any accents, bringing things to lowercase. Another technique is named entity recognition. And here the Spicy is a good library for that. So we label the text and detect whether it's a person or organization. It's advisable to do fuzzy matching to identify and catch misspelled or similar words. We can use for that Lewisian distance or cosine similarity, for example. And depending on the language, some parts, like some forms can be, some names can have different forms depending on the context in the sentence. For example, Marta and Martin in Polish. We can also use LLMs to help us in anonymization process. And how you do anonymization using LLM. You first split the text into chunks because of the length of the context window in LLM processing. So chunk by chunk, you prompt for PII detection, then search for all the instances of each PII. And it's important to ensure that PII exists in the text and that is identified even if the text has misspelled PII. So here the distance techniques work very well. Finally, we go to the reasoning stage. So once the documents are anonymized and structured, we do the reasoning, again with LLM. But here is a very important thing. We don't just look for yes or no answer. In claims processing, we want to see the journey. And we want to understand why the decision was made like that. So we need to break down the reasoning process step by step so that everything is explained, audited, and if needed, actually challenged. The way to do that is providing all the information in one place, maybe in Excel format or in JSON file that can be then stored in a database. But we want to break down the process as much we can. It's actually advisable to mimic how the claims handlers do the process currently. If they look first at the exclusions, we extract them. If they look at the main causes of insurance, we extract them. If they look at the general information or match the disease with the disease table, we do that. Bringing all of that and showing the whole journey of the decision making is important. But once we've structured the reasoning process, the natural question is, what kind of model should we use to power that reasoning? And we have two broad categories. The first one is open source models. So the one that you can run on your on-premises infrastructure, that you can access all the weights, you can freely play with that model. And the second class of the model is closed models. So those are models like GPT or Claude, and you access those models through the API calls. And choosing between those two is not only about the accuracy. There is a lot of factors you have to consider. Like three main are control and customization. In the open source models, you have full control of the model. In the proprietary model, it's limited to the vendor, what vendor allows you to do. Again, data privacy. Open source model, when you host it on your own infrastructure, you have the full control of your data. Data never leaves your company in that case. When you use the proprietary model, you are dependent on the vendor policies. And in terms of the cost, for the open source model, you have to build your own infrastructure if you want to run them on-prem. But for the proprietary model, you just pay as you go based on API usage. Now, whether you choose an open or closed model, you have to still have a critical decision to make. Which LLM is right for your use case? And to be honest, bigger isn't always better. A massive general purpose model may perform worse on your particular specific task than smaller, but domain specific models. So what should you consider when making your choice? Choosing the model is very, very use case specific. Are you processing image or text? When you process image, you need multimodal model. When you process text, you can use just inference model. How big is your input? So the context window. Are you analyzing long documents or very short documents? Like with that, there is a lot of information about retrieval augmented generation, but we'll not be discussing that. But the context window varies between models. And finally, there is a complexity of tasks, whether it's a basic classification, like extraction of information, or is it like multi-step reasoning where you have to have more powerful, potentially bigger model. So all of that is very, very use case specific. In fact, in my application, I used a number of models depending on the sub-processes. Like this solution is around 60 to 70 different prompts to different GPTs, to different models, LLMs. But yeah, if you decide actually running LLMs on-prem is what you want, you will have to decide on the infrastructure for your LLMs. I would like to give you some practical tips for deploying LLM pipelines on premises. Infrastructure is a huge topic, and I could spend another 40 minutes on that. But just couple of thoughts. So what I want you to keep in mind is that VRAM is not the only critical factor when selecting hardware for your LLMs. But at the same time, more VRAM allows larger models. Multimodal models require much heavier GPUs compared to the inference model. It's a very good idea to, when building your use case, to first use cloud GPUs, for example, Vast AI, to try different GPUs on hourly rate, at hourly cost. So that's what I actually did in my use case when I wanted to define the best infrastructure, the reliable infrastructure to run that solution on-prem. And the infrastructure should be chosen based on both LLM used and the use case. So that is very important when defining the technical requirements of your use case. And I'll stop here to allow for some questions. Thank you for your attention, and I will open the floor for questions.
Thank you, Małgorzata. As I was saying earlier, amazing presentation. This is an amazing topic. We do have some quite interesting questions from the audience. So I'll just start through the topics that have come up. So human in the loop. You spoke about, of course, this being largely an assistant so that the claims handler can verify and so on. What are the key steps in your process where you have this verification checkpoints? And I don't know if it's the case, but do you foresee eventually this getting through to let's say a straight through processing, kind of full automation for simple cases? And maybe can you give us a word on that?
Yes, sure. So currently, like this solution is used for helping claims handlers. There's always human in the loop. To be honest, like although the LLMs and Gen AI is rapidly growing, it's still very early days of that technology, I would say. And especially regulation is not catching up. And insurance is very highly regulated market. So regulation like AI EU Act classify insurance use cases as highly risky applications of AI and require kind of the constant supervision of those decisions and justification of that. That's why it's more for the human to decide. I'm not saying that the system wouldn't be able to make automated decisions, especially in very easy cases. For example, when we have a claim of birth, it's super easy because that kind of document is structured. Like each birth certificate has exactly the same format depending on country, right? But it's just few templates. Medical documentation is very, very unstructured. Each hospital uses different format. There are missing information. So all of that makes it much harder to trust and to leave it just for the automation. And with human in the loop, you can still automate the process, but keep the decision making and keep the responsibility for decision making for human.
Absolutely. So of course, as you say, triaging fundamental. You want to discern your simple, complex, and low versus high risk cases so that you know what's the sweet spot for, say, automation versus assistant. But as you say, and I think this is the key part, I think that the technology can be largely there, but our regulation, our governance, And even our organizations are not necessarily ready. It's a maturity process to actually enable straight-through processing. And I think there's also legal hurdles to be overcome. So I think it's important to start experimenting as an assistant, start triaging and automating the simple cases, making sure that the whole organization moves along, right? It's not just about a data scientist building a great application, but it's also about how process change.
Exactly.
There have been several questions about model fine-tuning. So did you use foundational models? Did you fine-tune them? If so, to what degree? So
For that particular use case, I didn't have to fine-tune the model. I did prompt engineering for sure. And like my approach for now was to break down the process to very simple prompts. It's like it's very important to just ask for one thing of the model, not try to solve the problem at once, just step by step, asking for justification, prompting maybe another model to validate that answer, and checking a model with a different prompt. So that's how I approach that, like a simple step. But fine-tuning may be very useful here as well, but wasn't necessary at that stage.
It's a different degree of complexity as well, where you need large volumes of labeled data, which you may or may not have, right?
Yes,
but it does imply a, let's say, slightly different type of project with a lot more interaction with the claims managers even than this, as you need the labeled data, which is custom.
Yes, exactly. And depending on the use case, for example, when we let's say classify serious diseases or classify surgeries, and there are different names, it might be worth to kind of train on that very specific use case. But like we have now so many good LLMs that can handle, like, it's pretty simple reasoning. Once OCR is done correctly, and so the text is extracted correctly, it's just asking the right questions and deciding on the right structure to show their thought process.
Absolutely. I think good prompt engineering, the right architecture can get you a very long way without going through the costly process of fine-tuning. We'll definitely be seeing it more when we start industrializing, because I'm not necessarily fine-tuning large language models, but actually using small language models that are very industry specific or task specific, as you were saying, which will certainly reduce the running costs. But that's more for the future. Can you tell us a bit about which models you used on, let's say, your own infrastructure versus the models that you decided to use third-party hosted or third-party managed through APIs?
Sure. So I was checking a large number of models, and I managed to get this application working both like for on-prem, so only using local models. This mainly was Llama 70 billion vision multimodal model for OCR. And for OCR, I used like a bunch of techniques, both LLMs as pure Python packages, cleaning that, so multi-models model there. For anonymization, for example, I didn't require large context window because I was splitting the text into chunks. You don't have to understand the whole logic to identify whether it's a name or a street. So I was able to use smaller models, smaller llamas. It was working well with quantized version that you can find in Ollama. That was this type of model. For reasoning, for the local version, llamas were working pretty good. And for the closed models, I I mainly used GPTs. GPT 4o Mini was very good, was good enough when I was building that for simple prompts. For more complex prompts, when you have to classify, check whether it's in different dictionary, like more advanced, more powerful GPT-4 models. So also within one application, it's good to have a mix and choosing the model not for the whole process, but for different parts of the process, deciding whether you have to process image, so you have to use the multimodal model, or you do the simple prompt. It can be maybe a small context window, or you have to have a bigger view on what's happening, the whole medical documentation, to make sure like this is aligned, everything is aligned, that like there is no fraud of submitting like inconsistent medical documentation in that case.
We were speaking yesterday, and we had a great discussion on anonymization, because there are, so of course there are, you have your models that are running on premises, so you can ensure that data is not leaving your data centers. When you're using third-party models, you are, let's say, you need to follow whatever clauses and conditions your vendor has, but you do have the possibility to configure those, and the vendors, the large hyperscalers, are quite conscious about, of course, they want to work, they want the applications of the clients to work compliantly with GDPR, data localization rules, etc. So there's also many options to configure those safely. However, you spent a significant amount of time on anonymization, which is largely about a prevention principle. Can you tell us a bit more about this? Because I really think it's something that our attendants would benefit to hear.
Yes.
That experience, like driving it through on real use cases and on the enterprise. And once again, how everything needs to move together and why this is beneficial.
Sure. So you are right. Vendors are very aware that data cannot be for the enterprise use cases. Data cannot be trained, used to train the LLMs. Data needs to be secured. But still, it's your responsibility, the insurance company responsibility for your client's data. So you have to be double cautious. I mentioned briefly this example. Although you anonymize the data, it's not 100% secure, because you can cross-reference that with the data that leaked from the different source. So, for example, the hospital documentation that has like the cyber attack could have resulted in your hospital data being exposed. And if the company is not careful enough with your data, even if they mask names and your address, but you can cross-reference with medical procedures. One can identify which insurance company you have your policy with, and that's actually a secure information as well. So, so anonymization is a big thing. Although you have some assurance that that data is safe and secure, you have to like take every measure on your side to anonymize and to protect that information. And also the GDPR has a principle of like the minimal use of your data. Whenever you need a name for an AI model to reason, you shouldn't actually be using that in an AI application. So it's not only about the data leakage, it's about all the regulation and the GDPR and this protection that is required by law.
Absolutely. I think this is a great illustration of a prevention principle, right? Where you just upfront want to keep your pipeline, so to speak, as safe as possible. I can also say from experience that, because once again, this technology really changes the way we work. And as in any, let's say, large transformation, you need to do it at an enterprise level. So it's not just about, just the claims department working with technology. You're going to be working with compliance. You're going to be working with information security, and just being safe up front, having that as a principle will help you drive through all the approvals that you need. Make sure that this is, still not necessarily low risk in a European regulation perspective, right? But as low risk as possible application.
Exactly. Also, data, because of GDPR, shouldn't actually travel between countries, between boundaries. So, because closed models are hosted in different locations, like you depending on the vendor, you can choose
Correct.
which location that the model is hosted. But to be extra sure, you should be protecting those information, especially that there are techniques that can help with that. So why not using them?
Absolutely. On data localization and infrastructure, I think there is also a great question, and you did touch on it, right? On self-hosted versus managed models, right? So can you speak a bit about how you see this? What would be those advantages? Where would you advise someone, go with a hosted type of service, or really internalize it? What would you think are the conditions, and once again, in the larger setting of the enterprise?
There are pros and cons of both. For the self-hosted, you have to care for you have to have this infrastructure cost, and you have to maintain that infrastructure. And because you run on GPUs, you have this like air conditioning of those servers. All of those costs you don't have to think about when running the model through the API calls. But I would say like the mix would be a perfect balance, doing OCR and anonymization locally, but then do the reasoning through the API calls. Once the data is cleaned, and once the data is anonymized, you can actually prompt closed models. That I would think is the safe, good solution.
I think it's a very good mix that you just stated. And just for the attendance, you'll need to be mindful of what Małgorzata said. Hosting a model in a GPU is not always up to the skills of every IT department. So make sure that you're involving your IT department, the infrastructure people know how to manage this, because yes, there's complexity in GPUs, there's complexity in managing a model. It's a new technology, and they need to know even simple things like how to upgrade it and troubleshoot it. We have 2 minutes left, so there have been several questions around performance, model performance, precision, so on and so forth. Can you just tell us what's the general setting with which you manage, you test, and so on?
For that application, I was validating the answers with another prompt, checking an answer with another model, and bringing that everything in front of the eyes of a claims handler. So having every decision validated. So that I was more focusing on explanation of each answer and validating, for example, the admission and discharge date. I was looking at the procedures and all the available dates of the document to make sure like the dates are not too far off. So those kind of mechanisms.
Great. Well, I think that we're on top of the hour. So I want to thank you once again. Amazing webinar, amazing topic. I hope that this was an interesting topic to you all. We will follow up on the questions that we didn't have the time to answer. And have a great, I don't know, end of day, beginning of day, afternoon, whatever it is in your time zone. Thank you very much, everyone.
Thank you.
Thank you, Małgorzata.